Hello class, this is CSE 4410, Section 2, Week 4, Spring 2026. I'm Giovanni Orijuela, and let's talk about modifying the base game that you made in Chapters 2 and 3 so it has, well, fewer bugs and more interesting features. So this is going to be a set of 3 modifications that you can add to your game that I talked about in class previously. So if future me is recycling this video in the future me might have even more possible additions. Past me also has one other addition in which he decouples the scripts for shooting and movement for the enemy. The idea behind that is if you decouple enemy shooting and enemy movement, you can have things that can move around but not shoot at the player, and then you can also have things that can shoot at the player but not move. So doing that is another way of decoupling your code so that you can better mix and match components to your needs. But let's talk about what's going on with your base game. So by this point, you should have the project as outlined in chapters 2 and 3 of the textbook, but the base features are lacking and buggy. Towards the end of chapter 3, I talked about those issues and a few possible additions you can add. Okay, so issue number 1, negative health. Issue number 2, the negative health, that implicitly means the player can still do stuff despite the fact that they're supposed to be dead. Here's another feature that I don't get into talking about, but having the scene controller spawn multiple enemies, possibly at multiple locations. Also, being able to track how many hits how many enemies you have to kill to win. So that is another possible feature we could add that I unfortunately don't talk about here. But maybe it's something that future me will talk about. Okay, but before we begin, there are a few small optimizations we can make this early on. Number 1, remove any unused update methods. So if you have an update method that's totally blank, good idea to remove it so that way it's a small amount of performance gains, which for a project this small isn't all that much, but it adds up for larger projects. Same thing for removing unused start methods, but that's more for the purposes of code hygiene. At this point in time, I had assigned to you programming assignment 2, in which you are to add 3 different additions to your game that you made in chapters 2 and 3. These aren't the only modifications you can make. These are just basic modifications that you can try out to get started. So change number 1 is going to have it. Change number 1: the player stops moving when the player's health reaches 0. This also fixes the negative health issue. So if you recall, there are 4 scripts associated with the player. Mouse look for looking around the scene, though there's actually another copy of the mouse look script that's attached to the camera, which is attached to the player. Player character, which currently only contains the player's health information. FPS input for moving around the game world. And ray shooter, which is again attached to the camera rather than the player, that is for shooting at enemies. So if the player's health reaches 0, we would like to turn off player movement and turn off the ability for the player to shoot at enemies. We could also disallow the player to move around, but it would be nearly similar code, and I'll talk about how you could make it so the player can't move the camera anymore upon death. So, for us to begin with this modification, first, add this line of code to the hurt method that is in the player controller script. This alone fixes the negative health problem. In the FPS script, in the FPS input script, add the following private field, private bool allowed to move, and then add the following method, public void set movement. This accepts a Boolean variable that we are just going to use to assign to allowed to move. In the start method of the FPS input script, assign allowed to move to true. Finally, in the FPS input script is all this code related to getting player input and then translating that to movement that is then passed on to the character controller. Enclose all that code in curly brackets and then right before that add if allowed to move. So this is going to be one big if. This is a big if statement in which if the variable allowed to move is true, we are allowed to execute all this code related to movement. So this means there is going to be something that sets allowed to move to false, and then that's gonna disable all player movement. You're going to then repeat these steps for the race shooter script. However, we're gonna name it a little bit different. The private bool is called allowed to shoot. The method is called set shooting. In the start method, you're gonna say allowed to shoot equals true. And because a lot of the code, well, nearly all the code related to shooting is already part of a conditional statement, the condition input.get mouse button down, we're just gonna add another condition to that. So it's going to be input.get mouse button down 0 and allowed to shoot. So those are the changes you're going to do to the race shooter script. Then, in the player character script, add two new private fields, race shooter and FPS input. Their data types are of course going to be FPS input and race shooter. So race shooter is of data type race shooter, FPS input is of data type FPS input. You can see where this is going if you're familiar with what we have done in the past two chapters. We are then going to use get component. We're going to say get component FPS input. We're going to assign FPS input the return value of get component. Race shooter is a little bit tricky, but there is another method that we can use. And that's because the race shooter is attached to the camera. The easiest way to get that component attached to the camera is to say get component in children. So this is a method we can use to get a component that is not attached to the player, but rather attached to something else that's attached to the player. So now we have references to our two components, FPS input and race shooter. Finally, in the hurt method, add the following code, health, if health equals 0, FPS input.set movement false, and race shooter.set shooting false. So your final script for player character would look something like this. So we have the health as it was already. By the way, there's no code over here, so you're not really missing anything by having my face camera over there. So take this moment to pause the video to make sure that your code is up to snuff. Okay, so that's the final code for the player character script. Here's the code for the FPS input, though the changes to that are pretty minimal. The only things we really added are allowed to move, set movement, an assignment operation in the start method, and enclosing all this code here as part of this if allowed to move statement. So take a moment to write this down, or just pause the video. Similarly, the race shooter script has undergone minimal changes as well. So allowed to shoot, set shooting, assignment operation, allowed to shoot equals true inside the start method, and we're just adding an extra condition for this. So if input.get mask button down 0 and allowed to shoot. So those are really the only additions you need for the race shooter. Take this moment to double check your code to make sure it's correct, or just pause the video. I will also be demoing all of these changes towards the end of the video as well, but you may notice that we've written nearly identical code for both of these two components, the race shooter and FPS input. There is further modifications we can do to simplify all this code. So in C#, there is no such thing as multiple inheritance, but the next closest thing to that is something called implementing an interface. So an interface would look something like this. So this interface is called I-toggleable. By convention, all C# interfaces start with an I. If you want to follow along with this change to change 1, create a new script called I-toggleable and erase all of the code inside of it. Remember, whenever you create a new script, it's going to add some boilerplate that includes, among other things, public class, class name, and then it inherits from mono behavior. This is going to be an interface, so it's not a class. In fact, it doesn't even inherit from mono behavior. So, what even is an interface? Well, think of an interface as a contract that says any classes that implement this interface must include any properties or methods specified in the interface. There's only one method in here, and that is just toggle behavior. So if you want to use an interface for change 1, and we do talk about interfaces in a later chapter, chapter 9. I'll show you why you would want to use an interface, and it's actually pretty cool. Because it simplifies a lot of the code that we wrote in the player character script. So again, here's the code for the interface. It's only like 5 lines of code even if you include blank lines. For the class definitions for race shooter and FPS input, add after mono behavior, add comma space I-toggleable. So now these two scripts must implement that toggle behavior method. And because we already wrote near identical methods to that anyway, you have a method called setShooter, just rename that to toggle behavior. Yeah, so setShooting is in the race shooter, just rename that to toggle behavior. And in the FPS input script, you had a method called setMovement, just rename that to toggle behavior. So now, at this point, you should have these interfaces implemented. And now, we can clean up the code for the player character script. Instead of having references to each individual component, it's an array of toggleables. So private I-toggleable, and then square brackets, so it's an array, toggleable components. Instead of having separate getComponent calls, we can get everything that has I-toggleable by calling the method getComponents in children. So that's plural, getComponents in children. So that's going to get everything that implements I-toggleable. And finally, in the hurt method, we had code that would turn off each toggleable. So originally it was separate statements for each component with an interface. All we need is a for each loop. for each toggleable component in toggleable components, and then in curly brackets, component.toggle behavior, and then pass in false. So the beauty of an interface-based implementation is, if you want to add new features, you do not need to add any more code. This will handle any features you want to add to your player. Doesn't matter if it's a jetpack, or an auto turret, or crouching, or running, or whatever. Any new features you add, any new abilities you add to the player requires no new code in the player character script. So if you want to go for the interface-based implementation, you would write the player character script as follows, and then you would make these changes in the race shooter and FPS input on top of the ones I talked about, just to implement these behaviors in the first place. So that's change number 1. The next 2 changes are contingent on adding UI elements. That's all the way in Chapter 7, but we can discuss some basics here. However, I must mention that Chapter 7 introduces something known as an event system, which is a means of broadcasting updates between different parts of the game without requiring references to those parts. The beauty of having an event system is, if you have parts that are missing, the absence of parts does not break the rest of the game. So the game will be able to work in an incomplete state, or the UI can work in an incomplete state. Basically, the game can work without a UI, and the UI can work without a game. If we implemented a UI in the way I show here, you risk having null reference errors, which is something that is avoided entirely if we use an event system. So this is a quick and dirty, what I'm showing is a quick and dirty implementation of UI elements that we can update. It's not the best implementation, but it is just enough to get started with making some basic UI elements. But by the time we get to Chapter 7, you might want to refactor that code so it uses an event system instead. Okay, so how do we get started with adding UI elements? Well, in the inspector, in the hierarchy, right-click the empty space in the hierarchy, go to UI, select canvas, and that will add 2 things. The first one is a canvas object in the sample scene, or whatever you name the scene, and something called event system. We're gonna ignore the event system here. We're just gonna be working with the canvas. The most striking thing when you add a canvas for the first time is the fact that it's huge. 1 pixel in the canvas corresponds to 1 unit in game in the Unity world. There's a little 2D button you'll see on the top of the scene view towards the right-hand corner, upper right-hand corner. Click that and it will straighten it out so you see it as it would, perfectly orthogonal. We can then add UI elements by right-clicking, going to UI, and in this case we just want a text-text mesh pro object. Name this one score counter. The first time you ever add a text-text mesh pro game object to your scene, you'll be prompted with a window that says do you want to import PMP essentials? If you are asked to do that, do so. Also, make sure that any UI elements you add are children of the canvas. By default, this should be the case, but just double check. When you add this text element, you can drag it around to position it anywhere on the screen. Here I have it placed in the upper left-hand corner. Keep it selected and then go to the inspector. You'll see an icon in the upper left corner of the rect transform. click on that, and you'll get these anchor presets. Select the top left anchor preset, and you'll notice that there was a little X on the screen that now should have moved to the upper left-hand corner. This is so that whenever you resize this screen to be whatever screen resolution, or I guess more technically, aspect ratio the screen is, the text element will stay, well, in the corner, and it won't move around relative to where it is on screen. So this is just to place the text element in the corner so it doesn't, well, move out or possibly off the screen. You might also want to resize this by dragging the resizing handles on the corners. So that's how we add UI elements to the screen. But we want these UI elements to change based on, for example, how many enemies we've killed. So we're gonna use UI elements to implement the next two features. The first one is a score denoting the number of enemies killed and an ammo counter. The chapter that talks about adding a UI does this in a more elegant way. As I said, this is a quick and dirty implementation that is still prone to issues that is then later fixed in the chapter for the user interface. Okay, so let's add a score counter anyway, and then we'll just refactor it later on. So the scene controller is responsible for spotting new enemies. Let's modify it to keep track of and increment the player's score. So we could just start and add code. If you look in the update method, we have code that spawns an enemy if there isn't one. If there isn't an enemy, that implicitly means, that implies that the player has shot down an enemy. And now it's up to the scene controller to spawn a new one. But think about this. The scene never starts off with any enemies. When the scene starts, the start method is called and does nothing because, well, it's either gone or you deleted it. But after the start method is called, the update method is called, the scene controller realizes there are no enemies, so it spawns one. So if we added code in this code block here, as part of the enemy spawning code here, if you incremented the score at this point, then the player will start with a score of 1, which is not what we want. So to prevent this, what we should do is spawn an enemy in the start code. So the game will start with 1 enemy. But in the start code, we're not going to add any code that increments the score either. So if we start with an enemy already spawned in, the player will start with a score of 0. But this would be near identical code in both the update and start methods. So let's just refactor this code so that we have a spawn new enemy method. We're going to write it as follows. So this method returns a game object, and it takes in as a single argument a vector 3 that denotes where in the world to spawn this enemy. So a lot of this code is going to be nearly identical to the original code down here. We're just modifying it so that, well, apart from the fact that we are going to rename a few variables, we are just going to instantiate a new enemy game object. We are going to place it somewhere in the world. We are going to rotate it a random angle, so it's going to go off in some random direction. And then we are going to return that new game object. Notice that in this code, enemy.transform.position was assigned a position that is new vector 3 010. We're passing that in instead. So that's some one modification we have to do here, in addition to naming the enemy to new object. So this is the code we're gonna call. This is the method we're gonna call in both of the start and update methods. There is one slight modification that I do have here, and that is, so I have the enemy spawn location set up so that is new vector3 0.80, but I add to that the scene controller's location in game. So this is itself an optional change. If you just want the enemy spawning at the origin, but at some height level to make sure the enemy is at the right level, just add everything up to new, just write everything up to new vector3. Don't add the plus GameObject.transform.position. If you want enemies to spawn exactly where the scene controller is, then just add in this whole line of code. So this is going to be the spawn location at which an enemy is going to be spawned at. We pass that in to spawn new enemy, and then we can just assign enemy to the return value of spawn new enemy. Copy paste these two lines of code into the update method down here. So if there isn't an enemy, spawn one. There you go. At the time, it's worth testing out the refactored code to make sure it works. But once we're done, we can go ahead and add code that we can use to update the score. So begin by using tmpro semicolon at the top of your code here. So all of these are different namespaces that your code is using. tmpro is a namespace that contains, among other things, the tmp text data type used for text objects in Unity. In the scene controller body of the class, we're going to add two fields. One is the score, so this is going to be a private int score, and we're going to add another private field, private tmp underscore text, score text. But we want to be, I said it's a private field, but we want to be able to edit it in the inspector, so add serialized field to it. So I should say before it. So serialized field, private tmp text, score text. In the start method, in addition to all the spawning code, we are going to set the player's score to 0. And then we're going to update the text in the UI by saying scoreText.text equals $ enemies hit, colon, and then enclosed in curly brackets, score. So this is how we can write stuff to a text element in the UI. Copy those two lines of code, paste it into this block of code here in the update method, but replace the first line of code, the score plus plus. So instead of score equals 0, say score plus plus. So if there isn't an enemy spawned in the scene, that implicitly means the enemy was killed by the player, so we're going to increment the score by 1, in addition to spawning a new enemy. Finally, select the scene controller so that, hold on, this has an error, hold on. Okay, so finally, open the scene controller in the inspector and drag and drop the score counter from the hierarchy into the inspector. That way, the scene controller has a reference to the score counter text element to which we are going to update the score. So when you play this game now, you should see an enemy's hit counter in the corner. You'll also notice that these players' score increments when the enemy despawns, or I guess also when the new enemy spawns. The implementation in Chapter 7 has it so that the score is increment upon hit instead. So there is yet another alternate implementation where if in the race shooter script, the player successfully hits an enemy, that's when we increment the score. So that is another alternate implementation that we can do instead. But again, the Chapter 7 implementation is more robust and less prone to errors. So we can leave it as this for now, but we might want to refactor our code once we get to Chapter 7. Here's the code for the final scene controller. So it has the responsibility of both handling the player's score. By the way, there's nothing underneath the webcam again. So here you go. So this is the final code for the scene controller. It is now responsible for both spawning new enemies and handling the player's score. So take a moment to make sure that this code matches yours. Now, we did not modify any other scripts. The only script that we modified was the scene controller. Okay. So, the last thing we're going to implement is limited ammo and the ability to reload. So, all these three changes were suggestions that were made in class that I am trying to implement, that I have taken the time to implement and explain here. We're gonna have the player have limited ammo, and depending on how you want the player to reload or get new ammo, you might only need half the information for change number 3. There are alternate ways we could give the player ammo, such as picking it up off of the ground, but that is all the way in an even later chapter. I believe that's chapter 9 on interactable objects. This is what I'm showing you here is a quick and dirty implementation for the ability to reload. So if you want to try this out for yourself, let's begin. So this implementation assumes that the player is going to reload rather than pick up bullets off of the ground. Let's add another text element to the canvas, or copy paste the one already there. Name this one ammo counter. Since the shooting code is handled by the race shooter, we're gonna add our reloading code to the race shooter. It's also a good idea to edit these two text elements so that they have the following default text: enemies hit equal 0 and ammo left 0. So in the race shooter, we're gonna add 2 private fields: private int ammo left and serialized field private TMP text ammo text. We're then gonna add code in the start method as follows. So we're gonna initialize the ammo to be 5 units of ammo, and then we're just gonna change the text to say ammo left, and then in curly brackets, ammo left. We are then going to add another condition to this. So this is contingent on the toggle ability features that I talked about in change number 1. If you are implementing both change 1 and change 3 here, you're going to have 3 different conditions. If that is the case, it's maybe a good idea to split it into 2. So if not allowed to shoot, return. So this is just going to skip all code after that. That way, we only have to deal with 2 conditions here. If input.getMass button down 0 and ammo left is greater than 0. Finally, in the hierarchy, select the scene controller again, and then drag and drop the ammo counter into the ammo text slot here. Now, when you play this game, you're gonna have limited shots to kill any enemies in the game. Okay, but what if I accidentally waste all my ammo and I want to reload? Let's talk about the reloading feature at this point. So, Chapter 9 talks about interactable objects more, which presents an alternate means of reloading ammo to the player. In the race shooter, we're going to implement the reloading feature as follows. If the player runs out of ammo and they try to shoot, it will have the player enter a reloading state. We are then gonna count down time, and when that time reaches 0, we are gonna get the player out of the reload state, and we're gonna give the player 5 more ammo. So we need 2 fields. The first one is for the reloading time left, and the other one is for denoting the reload state. We are gonna initialize both of these variables in the start method, so reloading time left is set to 0, and its reloading is set to false. So now we have, originally we have input.getMask button down 0 and ammo left is greater than 0. We're gonna add else if input.getMask button down 0 and ammo left equals 0. It's implemented this way because if you just said if rather than else if, what's gonna happen is the player is going to enter the reload state the moment they reach 0 ammo. But we want it so that the player must manually enter the reload state instead of the game automatically reloading for them. Also, it's a good idea. It might be a good idea to add a third condition to this. So input.getMask button down 0 and ammo left equals 0 and not is reloading. This extra condition makes it so that the player doesn't accidentally reset the countdown timer for reloading. Okay, so this is if and then else if. We're gonna write another if statement here. If is reloading, we're going to decrement time from the reloading time left. We're gonna decrement by time.delta time. Because this is a method this method is in the update method, and it is called every frame, and we want the reload time to be independent of the frame rate. So however much time it took to render the frame, that is how much time we decrement from reloading time left. If, during that time, if as we decrement, it reaches 0 or possibly goes below 0, that means time's up. We can now add ammo to the player. But there are a few things we have to do as well. We're gonna reset the reloading time left back to 0. We're going to say is reloading equals false, so the player is out of the reloading state. We're gonna add 5 new ammo, and then we are gonna update the ammo text UI element, so it says ammo left, and then it'll say 5 ammo. Oh, by the way, what I did not mention is in this block of code here, we also have it the player, we also update the text element so that it says reloading, so the player knows that they're reloading. Yet another change we could do that I don't show here is add the timer itself as part of the text. So I don't show that here, but that is something we could do to denote how much time is left. If you try these changes now, fire 5 times, and the 6th time you try to fire, it should enter that reload state. So the changes are all in the race shooter here. So take this time to make sure all your code is correct. It's split it into 2 parts, so this is just the variables and the start method. I'm not showing any unmodified methods. There are 2 other methods in this script that I'm not showing, that is onGUI and sphere indicator. Those are unchanged here. So take this time to make sure all this code is correct, ignoring onGUI and sphere indicator because those are unmodified. And here's the rest of the code. So this is all the update method, all the additions we made to the update method. Alright, so that's it for the changes. Let's look at these changes for ourselves in the Unity editor. Alright, so the game is now finally opened up. So here are the UI elements that I talked about: enemies, hit, and ammo left. So let's check it out. So I am gonna play the game now. Hit me. And there we go. The enemy hit me more than 5 times. I cannot move anymore, and you can probably hear me press the arrow keys and me clicking the mouse. No matter what I do, I cannot move or shoot anymore because the enemy killed me already. Oh yeah, one other change that I brought up in class but never mentioned here, we can add a better crosshair. So you're going to want to make a crosshair texture, and then use your choice of image editing program to make yourself a crosshair. Drag and drop it into your assets folder here. I highly recommend you add a textures folder, and when you add this crosshair, select it in the inspector and change the texture type to Sprite, 2D, and UI. And then, in the canvas, we're going to add another UI element. Image. Let's call this crosshair. We're going to reset the X and Y position to 0 and 0. That way it is in the middle of the screen. And in the source image field here, drag and drop the crosshairs. Oh yeah, sorry, my webcam was over the right transform. So these are the X and Y positions you have to change, and then just drag and drop the crosshairs sprite into the source image, and boom, we have crosshairs. You might want to shrink it down a little, so I'm just gonna change the width to 30 and the height to 30. There we go. Now, it's gonna have the problem of it's not gonna show up if it is over something that is pure white. So I'm just gonna select the crosshair and change the color to black. That way it's more readily visible on screen. But now it won't work if this is a nighttime scene. We're gonna not worry about that for now. So now we have a better crosshair. There we go. So we can fire at the enemy, I can move around, I can fire at the enemy again. If I miss, it's gonna still decrement ammo. I'm gonna try to hit again, and I'm gonna try to hit again, and I failed. So I previously demoed the player losing the ability to shoot and move upon death. I also demoed the score counter for the number of enemies hit. I'm gonna try to shoot again, and now I am reloading. Wait 3 seconds because I have it set to a 3-second reloading time, and there we go. I have 5 more ammo. I'm gonna try to chase down that enemy so I can try to shoot it again. It is way over there. So I want to get up close and personal, try to fire at this thing to get my score up and up. There we go. But that now means the new enemy should have spawned back at where the scene controller was placed in the world. There we go. Hit me. I said hit me. And he's hitting me. And I died. One thing I realize now that maybe we should add a health counter on the screen as well. Doing that would basically follow the same rules as that of the ammo counter and the enemy's hit counter. But yeah, it would probably be a good idea to add a health indicator in the UI as well. Once again, one thing you may have noticed is this. When I shoot an enemy, the score doesn't increment until the new one spawns in. That is an issue that is resolved when we implement the UI as discussed in Chapter 7, where instead of incrementing the score upon the enemy despawning, it increments upon hitting the enemy. But we need an event system for that. That's something you're going to have to wait until Chapter 7. Okay, so that's going to be all the additions for this discussion here, for this bonus video. I have these slides up on Canvas already. If you want to try out these additions for yourself, well, go right ahead. Maybe you can adapt this to adding a health meter for the player. Alright, so that's going to be it for this video. We're going to discuss the next chapter after this. And if future me has recycled this video, he'll probably talk about other, even more advanced features that you could add. Possibly a turret, or maybe a new bullet pattern. Alright, so that's going to be it. See you next video.